Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on scientific programming using Python. Now in the last tutorial we saw some examples of how to do matrix operations in Python. We saw how to use linear algebra solving mechanisms in programs. Uh, the function in the linear algebra packet class of numpy module to solve a system of simultaneous equations. Okay, and we also saw how to get an inverse of a matrix and p inverse of a matrix. Okay, and here in today's session we'll be continuing on how to get eigenvalues, eigenvectors, and vectors, and little more details into numpy matrices and the differences between numpy arrays and numpy matrices. Okay, now to begin with, okay, if you want to find the eigenvalues and eigenvectors in Python, it's rather very simple and straightforward. All you have to do is that you just have to invoke this command eig from linear algebra class of numpy library. That's it. So whatever you do, what you want to do is that just uh, pass a matrix, okay, for which you have to calculate the eigenvalues and eigenvectors, and this function eig will return the same. Now if you look on the left hand side, as the names indicate, when you invoke this function, it's going to return two values. Okay, and because of this unpacking mechanism, okay, the eigenvalues first will go to this first variable I global, and the eigenvectors of this matrix A will go to the second variable eigenvec. Okay, so that's how it is. Eigenvalues go to this variable. Eigenvectors go to this variable. That's it. Okay, and if you want to print them out, you can just use any printing mechanism of your choice to do it. So if you just print the eigenvalues, okay, this is how it is. Okay, so let me just run this up for you so that you guys can understand what's happening. Okay, now this matrix A is already available. And hold on, was I? Yeah. So let me just copy all this, and then paste it over here. Okay, run this up. There you have it. Now let me open it up and explain what's going on. See, this is actually your eigenvalue set. Okay, for this matrix A, which we saw last time. Okay, if you notice, this matrix has 5 eigenvalues, out of which only one of them is real. The first one is actually real, whereas the remaining two are whereas the remaining four are actually complex conjugates of each other. These two are complex conjugates of each other, and these two are complex conjugates of each other. Okay, similarly, eigenvec will have the eigenvectors. Okay, and the thing you have to notice here is that, let me expand this up. The thing you have to notice here is that wait, hold on, let me just expand all of this. Okay, and this a little bit, yeah. Okay, fine. Now the thing you have to notice here is that all the entries in the columns, sorry, in the rows, row wise, are actually the eigenvectors, if I remember properly. Okay, so this is actually a proper real eigenvector. Okay, whereas all the others are imaginary eigenvectors. So the column, so that's how you get eigenvectors of the matrix, and if you print them out, it prints out nicely, and if you want a better print, this is how you'll get it. Okay, the eigenvectors and eigenvalues and eigenvectors. Similarly, if you want to find the determinant of a matrix, okay, this det command inside linear alg is sufficient. That will help you to find the determinant quite nicely, and that's it. And for this matrix, the determinant is quite large, minus 287,952. Man, that's quite large in magnitude wise. Okay, and not only that, okay, all this time we were just working with arrays, numpy arrays. Now the thing is, there are a few people who might have worked with other programming softwares like MATLAB, okay, or maybe some other mathematical softwares like Mathematica or Octave and everything. Okay, for those kind of people who you know they're actually comfortable with matrices rather than arrays. Okay, now what is actually the stark difference between a matrix and array, okay, is as follows. At least this is how it works in Python. Okay, it kind of works similar in other places. Okay, in Python, okay, an array uh, array is different is same as matrix if dimension greater than 2. I mean number of dimensions, if its dimension is greater than 1, sorry, greater than 1. Okay, I'll explain what this means. See, it goes like this. Now if we have a 1D array, okay, okay, for example, a equals 1 2 3 4 5, like that. Okay, if you and okay, for convenience let me put 0 as well. Okay, a of 0 is 0, and similarly a of 5 will be 5. Okay, now this array is it uh, is it a row matrix? As we see in mathematics, is it a row matrix or a column matrix? Okay, this is one thing we have to keep in mind. We write it like a row matrix here. Okay, but it can be a row matrix or a column matrix. It doesn't matter here. That's the difference between a 2D array. That's the difference in 1D array. Okay, and now similarly, if you have a matrix like this, 0 1 2 3, like this, even then the same notations hold good. Okay, that's about 1D arrays. For 2D array, for a 2D array, let's say b equals 1 comma 2 comma 3 comma 4. Okay, we have to this is equivalent to a matrix 1 2 3 4. So as a consequence, if you want to access b of if you say b of 0 0 2, okay, there's no 2 over here, 0 1, okay, that means it looks for the zeroth row and first column. So zeroth row first column is 2 here, and if you want first row first column, okay, remember in Python the index starts from 0, so this is our first row, and this is our zeroth row, this is our first row. So first row first column is 4, like that. So we need 2 dimensions. Okay, similarly, okay, and one more thing is we can write the above statement like this as well. Not a problem. Okay, next thing is, let's look at matrices, numpy matrices. Okay, the difference here is that you do not have a generic 1D array 1D matrix here. Okay, matrices are always multidimensional. Okay, are always multidimensional, meaning, okay, never 1D. So for instance, if we have a row matrix like R equals just one row, like 0 1 2 3 4. Okay, but honestly it won't be like this, it will be like this. So as a result if you see, this bracket this parenthesis, square parenthesis on the inner square parenthesis indicates that this is one row, and as a result you have this as a result each element has its own index. As a reason, this is actually a row matrix, but the dimensioning goes like this. Suppose goes like this: 0 comma 3 will be equal to 3. Okay, so if you see, you need two indices. Sorry. Two indices minimum. Okay, here at least for a row matrix, and then similarly for a column matrix. Okay, for a column matrix like say C. Okay, if you want to write a column if you want to write a column matrix, how is it done is as follows: something like 0 1 2 3. This is how a column matrix is written. So if you want to access 3, you have to choose a third row and 0th column to access 3, like that, and so on. So here again, two indices minimum for multi-dimension and then indices are same for multi-dimensional n equal to greater than or equal to 2. Okay, arrays and matrices. Okay, that's one important difference in Python for NumPy arrays and NumPy matrices. Okay, some of the matrix format is actually used in programs like MATLAB. In MATLAB, what they have is that they don't have arrays at all. They just have matrices. All of them are matrices. So you won't have a chance of using arrays over there. Just one-dimensional arrays. Even a one-dimensional array over there is actually a matrix which has two indices, just like what we did over here. Okay, so if some people prefer matrices, some people prefer arrays. In my personal opinion is that I've been in both sides. I've used arrays, I've used matrices, both, so I'm comfortable with it. I don't have any I don't have any big issues with that, so it's not a problem for me. But some people are comfortable with matrix type of notation. So for those kind of people, NumPy matrices are beneficial. So coming back to the presentation, okay, if you want to enable matrix operations, use numpy.matrix. Okay, and that's it. That's about it. And that way, whatever array you declare inside, list, tuple, array, whatever, list, tuple, array, okay, whichever it is, they become a matrix because of this type conversion. Okay, and then there are a few things here, and we should keep in mind very clearly. If you want to do array multiplication or just element wise multiplication or matrix multiplication, okay, the thing is they kind of differ differ slightly. They kind of differ slightly between arrays and matrices in Python. Okay, I'll explain what that means. I'll give an example over here. Okay, see, if you look at over here, this explains for arrays, NumPy arrays, the star in NP multiply. Okay, the star and NP multiply are actually used for element wise multiplication. So if you have two matrices and you want to multiply one corresponding elements of some corresponding elements, or two matrices which have the same number of rows or same number of columns, okay, and you want to do a element wise multiplication of that, something of that sort, okay, then star or np dot multiply is will be useful for arrays, okay. And if you want to do matrix multiplication of arrays, then np dot dot is the function that you have to use. What you do is that you just do something like this. np dot dot a1 comma a1 is actually will do the matrix multiplication for you and will result the answers, give you the answers, okay. Now just a reminder, a1 is actually a numpy array and a2 is again a numpy array. M1 is actually a numpy matrix and M2 is again a numpy matrix. So if you look at the data types over here, you might not find a difference at all. This is array, this is A1 is an array, but this is a matrix. But when you look at the data, you won't find the difference. But when you do some arithmetic operations and all, then you might come into then you might find some differences between them, okay. You might find some differences between them. So in arrays, okay, be careful with the notations. As the star is actually used for element wise multiplication, and for array, if you are using arrays, you can use np you have to use np dot for matrix multiplications. For matrices, okay, the one small reversal happens, like the star is used for matrix multiplication, unlike arrays. In arrays, star is for element, here star is for matrix multiplication, okay. And similarly, as like arrays, np dot is also used for matrix multiplication, okay. So that's one thing in common. An np dot is actually used for matrix multiplication regardless of whether the entities are arrays or matrices. Doesn't matter. It doesn't matter whether so that's what I'm trying to infer here. If you use dot matrices, if you use np dot dot, okay, it doesn't matter whether the entries are matrices or numpy matrices or numpy arrays. It doesn't matter. Ultimately the end result will be a matrix multiplication. Will be a matrix multiplication. So not a problem. Okay. Similarly, if you use an np multiply, it doesn't matter whether the entries are arrays or matrices. Ultimately, what will happen is that you will get a result which is actually element wise multiplication, whereas the asterisk or the star asterisk symbol, okay, that operator behaves differently the arrays. It causes element wise multiplication in arrays and matrix multiplication in matrices. So be careful with that. And with that, if you are able to understand or differentiate these two accordingly, then it doesn't matter whether you use arrays or not, you will be in a position to clarify. So this is something you have to keep in mind. And to give you ensure that these are same, what I've done is that I've just written the matrices. I'm just printing the result. This will give you the matrix np dot will of a1 comma a1 will give you the matrix multiplication of a1 and a1 with itself. np dot multiply m1 and m1 will give you the element wise multiplication of m1 with m1, okay. np dot dot m1 comma m1 will give you the matrix multiplication of m1 comma m1, and mp dot multiply a1 comma a1 will give you the element wise multiplication again. So okay, you see, now what we do is that we compare these results to see how things are going on. We run this, check this out. This true command comes over here. The true command comes over here, and after that, okay, this first line is actually dot product. It's nothing but matrix multiplication of a1 and a1, so you get a matrix like this. Second, what you have is that m1 comma multiply m1 comma m1 is nothing but your matrix multiply, just your element wise multiplication, because if you look at A and compare the results, the first element is 25, this is 5 square, this is 6 square, this is 4 square, this is 3 square, this is 3 square, like that. And if you look at it, you're able to you see the pattern over here. This is clearly indicating that multiply is actually an element multiplication. And if you see the dot product, thing to notice is that this is a multiplication of two matrices. Okay, and this is the dot product of the two matrices, and it results the same as the dot product of two arrays, numpy arrays. The same result. This is the result we got over here. This one, okay, and we are getting the same result over here. Not same as that. And similarly, if you look at the matrix multiplication of two arrays, element wise multiplication of two arrays a1 and a1, this is the element wise multiplication of two matrices m1 and m1. Okay, both of them are the same. Okay, that is your proof to show that matrix multiply and dot products are same. So in case if you are very doubtful as to, you don't know whether the matrix, whether you are having arrays or not, you're not sure about it, always use np dot dot or np dot multiply so that you're safe. But on the other hand, if you're completely confident that you're using only arrays or something, only arrays, just make sure that you understand the differences between them and use them accordingly. So as the result, that's it. For arrays, star means element wise multiplication, use dot for matrix multiplication. For matrices, use star means matrix multiplication, use np dot multiply for element wise multiplication. Star changes its feature between operation and the characteristic based on based on arrays or matrices. That's all I have for you guys in this tutorial. Thank you guys for watching, and in the next tutorial we'll see how to do integration in Python. So see you guys then.